Morning, Algebra 1. We are starting our last two-day lesson today. I know, we got today and we got Thursday to do some new stuff. And I'll probably just give you a real quick wrap-up assignment Monday, and that'll be the end of our year together, unfortunately. So, let's get started. We've been factoring quadratic equations a lot. We've been making factored form, and we learned some different way to solve them previously, and now we're going to use factored form to actually solve equations that look like this, and tomorrow we'll look at equations that look a little bit scarier than this maybe. So let's begin. So we're going to write an expression in factored form, and then we're going to use that factored form to identify which two numbers would make the equation true. Now we did this briefly a little while ago, but just not with factored form. So we're going to go ahead and figure out which numbers multiply to get us negative 35. So let's see, we got 35 and negative 1, and we got 7 and negative 5, and the negative can go either way. And it has to add to give us negative 2. And we're back to that rule because, again, when our x squared is a coefficient of 1, we want to think about which combination is going to get us a sum of negative 2. So I'm thinking, all right, 7 and 5. Well, negative 7 times 5 would work. So that means that my factored form has got to be x minus 7 and x plus 5. And then from there, I would take my equation and say, all right, well, in this case, by the zero product property, I could either let x minus 7 equal 0 or let x plus 5 equal 0. In that case, I would get x equals 7 or x equals negative 5. So that's what we're going to do today. We're just going to factor some stuff and set it equal to 0 and just find out which two numbers make it true. And that's all. So we'll probably do some stuff that's easier to factor today just because it's simpler steps, and maybe stuff that has one more step required as well. So the two numbers that would make the equation equal to 0 are 7 and negative 5. So that's really our goal, to find those two numbers to make it work. So we've taken our expression, factored it, and then set each factor equal to 0, because 0 times something always equals 0. Remember that we talked about 0 times anything equals 0. So as long as one of these things equals 0, it'll work. And that's really the goal of solving this stuff. If I have an equation that equals 0, I can solve it easily. If it doesn't equal 0, it's going to be difficult. So, for example, if I look at problem 3, if I want to solve this equation, I didn't even change these names, I'm sorry. Tyler, who's not in our class, wrote out the following steps. See what he did in each step. I'm going to write it down for you because it is June something, and we're just going to listen to me. So here's my original equation. And in the first step, what Tyler does is the 99 scooches over to the left-hand side. The 99 goes over there. And basically what happened is we set the equation equal to 0. In this case, what we did was subtract 99 from each side. And then in step 2, we factored it. We took this and wrote in factored form. Oh, two numbers that multiply to get 99. Okay, 11 and 9. And the difference between them is 2. So negative 11 plus 9 gets me negative 2. And then we set each factor equal to 0. So say, all right, what if that equals 0? And then what if that equals 0? We get 11 or negative 9. And that's really what we did here. Those are really our four main steps. I'm going to write this in some nice pretty color. I'm going to write it in, not red, red's ugly. I'm going to do purple. We're going to highlight it in yellow. Why are there black boxes there? Okay, whatever. No highlighting, just purple. So, those are our main steps. That's how we're going to solve all these equations. Those four simple, not so simple steps. And we'll do, look at our form. We'll do a couple in the video. It's not going to be a crazy long video. The live's going to be where all the meat is, really. So we're going to do problem 4, and we're just going to look at A, B, and I will save C for later. What do we do these for? I'll cut off the lesson here. And if we get farther in the live, cool. So we're going to solve each equation by rewriting it in factored form and using the zero products property. And again, that property just says if two things multiply to get 0, one of them has to be 0. So I got a factor. So what two numbers multiply to get 15 and add to get 8? So I should be thinking in my head, all right, 15. 5 times 3, 15 times 1. Well, 5 plus 3 is 8. So I've got to have x plus 3 times x plus 5. Because 5 times 3 is 15. And then when I'm distributing, I'm going to get x times 5 is 5x, 3 times x is 3x. That gets me my 8x. So I factor and get that. So then my next step is setting each piece equal to 0. X plus 3 equals 0, and x plus 5 equals 0. So then I'm going to get x equals negative 3, or x equals negative 5. So again, we've almost always got two answers here. Sometimes there will be one, and you'll talk about 0 solutions when you're a junior in high school. So that'll be fun. No, I'm sorry, a sophomore in high school. So, done that one. Factor, set equal to 0, solve. The solving is sometimes one step. It's sometimes 2 steps. If you have like something with a number out front, it's usually 2 steps, but otherwise it's just typically 1 step to solve. And even if it's 2 steps, it's easy to solve. So, B. Notice here we don't have it equal to 0 already, so my next step has to be, I'm going to copy this down here, subtracting 5 from each side. So I get 0 here, and 12 minus 5 is 7. Took away 5 from each side. Hopefully that's visibly obvious, but that's what I did. So now I'm going to write this in factored form. Well, multiplies to get 7, that's nice and easy. 7 times 1 is 7, and oh look, 7 and 1 is 8. But since this is subtraction, I have to do negative 7 and negative 1. So I need x minus 7 and x minus 1 equals 0. So that means that x minus 7 equals 0, or x minus 1 equals 0, which means x equals 7 or x equals 1. Sorry if I'm going way too fast. But we've done factoring before. We're doing this. We've done factoring. We can take each piece and set equal to 0. That's no problem. And then we can solve these equations. The hardest part about algebra, I've said it for so much of the year, the hardest part about algebra is almost always the first step, dealing with this ridiculous thing right here. And every step after that, it gets a little bit easier, a little bit more familiar. But that first step is almost always the hardest, and that's probably not going to change until you're done with algebra. So sorry. But that's going to stay that way in Algebra 2 and in pre-calculus. The first step is almost always the hardest. So let's see, letter C. These are always fun. Two numbers that multiply to get negative 49, and add to get 0. Well, 41 times negative 1, negative 49 times 1, 7 times negative 7, bingo. 7 plus negative 7 gets me 0. So that means I have x plus 7, x minus 7 here. Because when I distribute, I'll get negative 7x on the outside and plus 7x on the inside. And those will cancel. Sometimes people call this a difference of two squares, some square term and another square term being subtracted. And it always looks like this. X plus the square root and x minus the square root. That's how I learned it in school, but I'm still supposed to teach this way. So now I know in this case that x plus 7 equals 0 or x minus 7 equals 0, and x would equal 7 or negative 7. So again, once I've factored it, so again, hardest step is the first one. Once I've factored it, it's easy, simple, well, straightforward. I don't know. Once I've factored it, I don't have too much crazy math left. It's just letting each piece equal to 0. I'm not trying to say it's easy. The stuff is like not phenomenally easy. I just look at all these word problems in real life applications, right? Like seriously. So letter D. This one's a little bit tricky because again I have some stuff to do. I cannot just say -4 and -5 because I have this thing here as well. The zero product property does not apply because I don't have two things that multiply to get 0. So I'm going to distribute it out, simplify it, and then factor it again, which I know is an exorbitant amount of work. But a lot of realistic applications would actually look more like this. So let's see. Distributing it out, I got an x squared. Let's see, then I have plus 4x plus 5x, which is really plus 9x. And 4 times 5 is 20. Then I've got that -30 to deal with. All right, and then, hold on. Then I've got the same thing, but -20 - 30 is -10. So then I've got to factor this. See, multiplies to get me 10, -10, and adds to get me 9. Okay, so I'm going to go with, let's see, 5 and 2 would get 7, 10 and 1 would get 11. 10 and -1 gets 9, though. Okay, so 10 and -1. So let's see, we got x plus 10, x minus 1. Because 10 times -1 is -10. So then I got -1x plus 10x is going to be positive 9x. And again, that equals 0. We're solving an equation, so don't forget that. And then, so my next step would be x plus 10 equals 0, or x minus 1 equals 0, which would then get me x equals -10, or x equals 1. So, we've had a lot of examples here. We've seen a lot of different things. Tomorrow we'll talk more about solving equations with it, like solving like more involved equations, maybe equations that have a coefficient out front. Actually, no, I'm gonna throw one of those in here right now. So give me 1 second to come up with one. I'm gonna do the work off camera actually, so that you can't see what I'm doing. It's actually a great idea. Okay, so we're gonna solve, the very last one is, we're gonna do E. It's going to be 10x, insert equation. We're 10 x squared. Then we're going to do minus x minus 3 equals 0. We're going to solve this one. Because, like, it's not crazy. The factoring is not wonderful, but, you know, it's there. And the solving isn't bad either, but just something else to be aware of. So notice this one, this is our first one where we have an a in front of the x squared. We have a number in front of the x. But you guys did a pretty good job within the homework. It wasn't like, it didn't go like awesomely, but like it was fine. Some of you are definitely using Google, and some of you are definitely giving it your best. So there's that. But I mean, like, what are you gonna do? So here we want to think about, for our first number, what numbers multiply to get us 10? So let's see, we could have 10 and 1, or we could have 5 and 2. Then for the end, we could really have 3 and -1, or -3 and 1. Those are really our only options. So I'm thinking, let's see, I always like to start with the 5s and 2s first, to be honest. Like, this just seems more reasonable to me. These ones always seem to get bigger numbers. So I'm going to start with a 5 and the 2. So I'm going to think like a 5x plus 3, and then 2x minus 1 is one option. The next option is going to be like 5x minus 1, and then 2x plus 3, and then just flip-flopping the signs of all that. I honestly have no idea which one the answer is. I just did the math and I forgot which one the answer was. So let's see, we'll do 5x minus 1. I'm sorry, 5x plus 1. No, 5x, oh my gosh, minus 3. Just change the signs, plus 1. Then 5x plus 1, then 2x minus 3. Okay. So I'll check these 4 and see if they work for anything else. So let's see, okay, 10x, let's see, minus 5x plus 6. Okay, so that got me. So it's 10x squared minus 5x plus 6x. So it's minus 5 and plus 6 gets me positive 1. So it's this one, but with different signs, because I have a negative x instead of a positive x. So I need it to be this one over here. It's got to be this one. That's got to be my winner. Because it's the same numbers, different signs. So if I do that one, oops. I don't want to bother using the tab key. If I do that one, I'll get 10x squared plus 5x minus 6x minus 3. There we go. 10x squared plus 5x minus 6x minus 3. And that'll turn into just minus x. So that's my winner. So then, to solve it, I have to take each piece and set it equal to 0. So 5x minus 3 equals 0, or 2x plus 1 equals 0. So if you're looking ahead, you might be like, no, these numbers are going to be ugly. And, like, they're not ugly. They're just fractions. It's very rude to call fractions ugly. But, you know, makes life more difficult. That's okay. So we did one step. They're not solved yet. So x is going to be 3/5, or 0.6. On your exit slip, the answers are going to be written as fractions, not decimals. And here we got x equals negative 1 over 2, or negative 0.5. So really, we still get answers. They're fractions, they're decimals, they're ugly, but that's okay. We factored, we solved, we set equal to 0. So that's just one more thing to look at. This, what do we have here? So that should be plenty to get you on for your movie today. That should definitely get you through the exit slip. Now let me know if you have any questions. I know it's technically not graded, but it's still good to, like, you don't want to finish the year strong. And, like, maybe if you do really good on this one, I can override a previous fail. That's what I'm gonna do. If you pass this one but failed a previous one, I can override a previous fail. That's it. I'm gonna do that now. Good idea, Mr. Obada. Okay. Okay. Movie's over. Have a wonderful day and enjoy your math.